righty. We are going to skip to temperature conversions. So the conversions that you can do are moving from Fahrenheit to Celsius or to Kelvin. Those are the three different, whoops, that would not be helpful if we actually see it. All right. So our three different ways that temperature is measured is in Kelvin, which is K. It does not have a degree sign. Fahrenheit does have a degree sign, and Celsius also does have a degree sign. And those are the formulas that we use to get from one to another. So obviously the first two formulas are a little bit more complicated. So if I'm trying to get to Celsius and I know my Fahrenheit, I need to be sure that I do this part first in the parentheses before I come back and I multiply it by 5 divided by 9. If not, you get the wrong answer. Same thing here. I know my Celsius. I want to get to Fahrenheit. I have to do this first and then add my 32. Get a little confusing on this sometimes. And so I'm a little bit more lenient on that. I'll show you one on your practice later. There's not really a good example here. When you add 32 or when you add 73, and by the way, on this one right here where it says 73.15, we're just going to do the 273. When I add those numbers, those are considered like constants. So in other words, they're not going to affect my sig figs. Even though we write it as 273, it's really 273 with zeros for a long, long time. So they're not going to be changed. Same thing with the 32. So that's why they don't affect the sig figs. So your sig figs are going to be coming more from what you start off with, not so much whenever you add those different numbers to it. All right, so let's just look at a couple of them to start off first. So I have Celsius and I want to convert it to Fahrenheit. So I'll be using that formula. So degrees Fahrenheit is equal to 9/5 times my degree Celsius, which is 10. And then I need to add my 32. All right, so I want to try that in your calculator and see what you get. That's not a subtraction, that's a multiplication. So hopefully you got 50 degrees Celsius. And that would actually be the correct number of sig figs. Because once I add that 32, even though it was only one sig fig, at some point, once I add the 32, it would become 2 sig figs. So once again, I'm a little bit more lenient because this can get really confusing. So if you put a decimal or if you would put a 0.0, I would also accept that on temperature conversions that we're doing right here, especially some of these harder ones. Yes, ma'am. Oh, thank you. Fahrenheit. All right, why don't y'all try same formula? Try 30 degrees. What's that going to be in Fahrenheit? All right, what did we get on that one? 86 degrees Fahrenheit. It's a good number, so that's what we'll go with. Now, if we're have Fahrenheit and we're converting to Celsius, now we're using this one where you're subtracting 32. So on my first one, 32 degrees Fahrenheit, what's that going to be in Celsius? I need to put it in my calculator? No, because why? Remember, I got to do this first. 32 minus 32 is 0, right? So when I multiply 0 times 5/9, it doesn't change it. So this would be 0 degrees Celsius. We usually tend to measure things in Fahrenheit. So 0 degrees Celsius, 32 degrees Fahrenheit, that's when water freezes on 2 different scales. All right, so let's try one that we actually got to do a little bit of work with. So my Celsius, 5/9 times 45 minus 32. And I need to do the parentheses part first. 45 minus 32. On that one, what do we get? 7.2. 7.2 degrees Celsius. So if we talk sig figs on this one, 45 minus 32 would give me, what, 13? So that's 2 sig figs. So when I multiply it by 5/9, my answer should be in 2 sig figs. Then we have the nice easy one that we really end up using the most. If I have degrees Celsius and I want to get to Kelvin, I just have to add 273 to it. I don't have to do all that other stuff. So 18.75 plus 273. That's all I got to do on that one. 291.75 K. Once again, if we talk sig figs on that, this had 2 places behind the decimal. So when I added 273, which is really 273.000, then that's why I would have 2 places behind the decimal. All right, why don't you give these next 2 a try? All right, what did we get on our 88? It should be 360, right, for sig figs? But if you put 361, I would also accept that. Once again, 270, I'm sorry. Oh, yeah, I'm really having trouble with my. With that part of it. All right, and then on this one, what did you get? 250, or I would have accepted 253 K. Okay, and once again, the reason I'm doing that is because the fact that you're adding 32 or subtracting 32 or adding 273, it gets a little bit confusing sometimes. So if you, the back of your practice real quick, I want to show you something, and I don't want to accidentally run out of time. Mine. So that says 98.6 degrees Fahrenheit. So that one right there. All right, so first of all, I'm going to change it to Celsius. So my formula for Celsius is going to be 5/9 times 98.6 minus 32. All right, so what did we get for our answer? So this is a good example. Sig figs should really be 37.0, But if you put just 37, that I would accept that also. So that's kind of a good example of what I mean. And once again, sometimes it just gets confusing, especially when you're using sig figs at the beginning, if you have to use it in add or subtract, and then you have to use it in multiplication or division. Okay. All right. Any questions on that part? All right. So if we'll go back to our notes, we will do scientific notation. Scientific notation. And you're live. A little bit. All righty. A little bit. All right. So scientific notation is a shorthand way of writing a really large or really small number. So in scientific notation, a number is written as the product of two factors. So if we look at a number that's in scientific notation, and we talked about this with sig figs, this part is called the coefficient. This part is the base with the exponent. And whenever we use scientific notation, the base is always 10. Your sig figs come from the coefficient part. So when you've done it correctly and you moved your decimal either backwards or forward, you should only have one number in front of your decimal. So in other words, if I wrote this as 123 times 10 to the second, that's really not truly written in scientific notation, because really it should just have like this one, just one number before the decimal. Right. So if the number is greater than 1, so a really large number, you're going to move the decimal to the left until you have passed the first non-zero number, or until there's only one non-zero number that would be in front. The exponent does not necessarily tell you how many zeros. Okay. Sometimes they match up perfectly, but sometimes they don't. Move this a little bit. Like for example, that 280 million, even though it's not written, we assume the decimal's right there. And I'm going to move it 1, 2, 3, 4, 5, 6, 7, and 8. I move it until there's just one non-zero number in front of it. So then it becomes 2.8 times 10 to the 8th, because that's how many places I moved my decimal. Remember, your sig figs should stay the same. So in other words, when I started, I only had 2 sig figs. So when I write my scientific notation, I only want 2 sig figs too. And then if our number is less than 1, then we're going to go the other way. Same thing until you pass the first non-zero number, but your exponent will now be negative. So these are for really small numbers. And once again, does not always represent how many zeros. So on this one, I have 3 sig figs. So I want my notation to have 3 sig figs. So I'm going to move it just until I pass the 2. 1, 2, 3, 4, 5, 6, and 7. So it becomes 2.8 times 10 to the negative 7. And I maintain that correct number of sig figs. All right, why don't you give those other 6 right there try real quick? No. All right, what do we get for our first one, our 45,000? 4, perfect. What about that number? 2.5. Negative what? -4. All right, what about on our 7 billion number? And we'll do one more little one. 3 times -6 or 7? -6. All right. Notice we only had one sig fig. We also have one sig fig at the end. So that's kind of what this little bold thing. Just remember to maintain your significant figures. All right. So if you look at your practice, now do y'all remember doing them ever in school? Right. Was that y'all's COVID? What was y'all's COVID year? 7th grade? Like a lot of, there seems like now there's been a lot of COVID years. All right. Practice and see if I can find mine. So we already talked about the one with the temperature changes. So on the other side, you're doing different things with scientific notation. So you're either have something and you need to change it from scientific notation to standard form, which is what we're used to doing, or vice versa. When you get to part C, your answer should be written in scientific notation. And also make sure that you maintain the correct number of sig figs down there on the bottom, because you're going to do that calculation in your calculator. And then you have to look what you started with. So for instance, on this one, number 1, how many sig figs do I have for my 6.02? 3, and my 8.7? 2. So when I do my answer in my calculator, it should only have 2 sig figs. So make sure you make those adjustments too. All right, y'all got a couple of minutes. Why don't you try a couple at the top, because we haven't done them that way. We've just been doing actually writing. See if you have any questions before we head to lunch, everybody.